When I'm looking at trajectories, what's the point? The trajectory itself is a point. Each trajectory is a point in this vector space. Right? The way you can look at this is something like this. You have a three-dimensional space. Right? So each point in the three-dimensional space is like a trajectory consisting of three entries. Right? If I'm looking at a discrete trajectory in time, so you have a set of infinite points. So it's like you can look at this as a single vector with infinite points. So if you join zero vector to that point, it will give you a point. Right? Now this is something like uncountable infinity. So what you have when you are looking at these trajectories is the number of points is uncountable infinity. If you are looking at a discrete trajectory, you have countable infinity. Here you have uncountable infinity. So you have uncountable infinity. You have an infinite number of points. But still, it's like one trajectory is like you can look at this as a sequence of infinite points. Yeah, that defines a single trajectory. That's like a point. Just like a point has three coordinates, the value that it takes along at each point along this line gives you the coordinates of this trajectory. Yeah, so this trajectory is like a point. So the points here, the points in this space are trajectories. Now, if from one trajectory you want to move to another trajectory that's very close by to this, how will you look at that?
So shifting the x part like limits of a and b only to the x axis.
Limits of a and b? No. See, your trajectory is still this. Why would you want to? So if you shift a and b, then your vector space doesn't remain the same, right?
So take the increment.
Take the increment where?
Sir, the trajectory from which you are required to move, and then we shift.
So you need to have a set of directions, right? So when you, for example, when you looked at maxima, you had this multi-dimensional maxima minima. What do? You took d by dx equal to 0, d by dy equal to 0, d by dz equal to 0, and so on. So you moved along certain basis directions. So what will be the basis directions here?
X and y.
X and y.
Axis.
Your points are not x and y. Your points are trajectories. So what are the basis trajectories here?
Oh, okay. Sine omega t and cos.
You are looking at finite. So for sin omega t, cos omega t, you can take when you are looking at periodic trajectories. So I am not looking at periodic here. So if I am looking at finitely supported trajectories, or I am looking at square integrable trajectories. So if I generally look at this, so what will be the? So if I look at square integrable trajectories, that's the most general set I'll be taking. So what will be the direction that you can move on? So suppose you're looking at trajectories that are periodic, that repeat after a certain period. Then you can look at increasing one of those sine components slightly. So you have those Fourier components.